Welcome to lesson number 1 on atomic theory. Our lesson objectives describe how the modern model of the atom has evolved over a long period of time through the work of many scientists, describe Rutherford's gold foil experiment and the conclusions that he made, and relate experimental evidence to the models of the atom. So we're going to start off our journey for the development of the atom with Democritus. And Democritus did a very simple experiment. What he did is he took a seashell and he started breaking it apart into smaller and smaller pieces. And eventually he was left with a fine powder, and he realized he could not break those small pieces up any further. He said they were indivisible. And he called those small pieces then atomas. So his model proposed that the atom is the smallest piece that any substance can be broken down into. I'm going to fast forward to Dalton. Dalton also believed that all elements are composed of these tiny things called atoms. He also said that all atoms in an element are identical, meaning that if I have a sample of copper, it's made up of only copper atoms, and that different elements are made up of different atoms. So copper is made of copper atoms, and silver is made of silver atoms. And so his model is essentially a billiard ball or a round sphere where there's nothing inside it. That's the smallest thing that we have. J.J. Thompson, he took this model even further, and he actually discovered that there were negative charges stuck inside this atom, or embedded. And he called these negative charges electrons. And he discovered that using a cathode ray tube, which we're going to talk about in a moment. But his model was called the plum pudding model because it looked like a bowl of pudding with plums stuck in it. So these things that are stuck in it are the negative charges, and he believed that there was a uniform positive charge throughout the entire atom, and the negative charges were just kind of embedded in that. So what is a cathode ray tube? Well, it's a vacuum tube, as you see here, that has a beam of electrons passing through it, and what Thompson did is he took a magnet, and when he put the magnet close to this beam, he noticed that it deflected one way. When he turned the magnet over, it attracted. So he concluded that that beam had to be negatively charged, and he called those things electrons. And this is actually the way that the old school TVs work, like the one that we have hanging in the classroom. They use a cathode ray tube here, and essentially there's a magnet going around it, and the magnet is going to deflect that beam of electrons into certain parts of the fluorescent screen on the front, giving us our image. So let's check your understanding. Can you describe the modern model of the atom and how it has evolved over time through the work of these many scientists? And can you relate experimental evidence to the models of the atom? Ernest Rutherford, he actually set out to kind of highlight Thompson's work and look at Thompson's model. But in doing so, he actually led to his own discovery and his own proposed model of the atom. And Rutherford proposed that there's a small dense positive nucleus, not a uniform positive charge like Thompson, and then that most of the atom then is just empty space. So what led Rutherford to this conclusion? Well, he set up a gold foil experiment. What he did is he took a thin sheet of gold foil and he shot alpha particles, which are positive charges, at this thin sheet. But he can't see them, so what he did is he set up a fluorescent screen around that, and when these particles hit the screen, they light up and he can kind of see where they're going. And what he thought was, using Thompson's model, that the particles would all go straight through. And what he got was something slightly different. Most of the particles went straight through, and some of them deflected, as you can see here, or even bounced back at him. And so he proposed that the atom then is made up of mostly empty space, and whatever it was hitting had to be small because it only happened 1% of the time. And since he's shooting a positive charge at these atoms, and they were deflecting or bouncing back, they had to be coming close to or in contact with something of the same charge because like charges repel each other. And so he concluded that that small thing that it was hitting had to be positively charged. So again, his two conclusions: most of the atom is empty space, and there is a small, dense, positive nucleus in the center of the atom. So let's check your understanding. Can you describe Rutherford's gold foil experiment and the conclusions that he made, and can you relate experimental evidence to the models of the atom? Now let's look at the more modern theories. So Niels Bohr, his model is often referred to as the planetary model because he believed that we had this nucleus, as Rutherford said, but that electrons were not just kind of haphazardly outside the nucleus, but that they were actually in defined energy pathways called orbits, and they were essentially orbiting around the nucleus like planets around the sun. And he believed that these electrons were in these different orbits and they possessed different amounts of energy. And in class, we're actually going to do an experiment that Niels Bohr did and see how he came up with this model. And lastly, through the work of many scientists over many years, we have the present-day model called the wave mechanical model. And the wave mechanical model looks something like this. This is what we believe the atom to look like. And the idea is that we can only determine the probability of finding an electron. We don't know exactly where it is at any given moment, but there's certain regions of space that we have a high probability of finding electrons there, and we call these regions of space orbitals. So just like any model development, they get more complex over time. So if we're looking at the kind of history or development of the model, we start out with the billiard ball, which is Dalton. Thompson discovered electrons. Rutherford discovered that there was a small positive nucleus with electrons outside. Niels Bohr is the planetary model, that electrons are in these defined pathways called orbits. And then the quantum or wave mechanical model, our present-day model, is that there's a high probability of finding electrons in certain areas, which we call orbitals. So let's check your understanding. Can you describe the modern model of the atom and how it evolved over time through the work of many scientists? And can you relate experimental evidence to the models of the atom? At this point, you should be able to describe the modern model of the atom and how it evolved over long periods of time through the work of many scientists. Can you describe Rutherford's gold foil experiment and the two conclusions that he made? And can you relate experimental evidence to the models of the atom?